In this video, we're going to be talking about factoring trinomials again, but this time where a is not a 1, and we can't factor it out as the GCF. So again, a trinomial will take a general form of ax squared plus bx plus c, and in this video we're going to we will be talking about when a is not 1. For example, let's look at this example on the left, where a equals 4, b is a -5, and c is a -6. So I start by assessing if there's GCF. There's not. I have my a, b, and c, and this time a is not 1. So remember in previous videos I said we wanted factors that multiply to a times c. So now a times c, I actually have an a other than 1. So 4 times a -6 would give me -24. And I still needed to add up to my middle term, which was -5. So factors of 24, again, I could list them all: 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. But I want them to add to -5. So the only ones that look like they have a difference or can be combined in any way to make 5 would be 3 and 8. But I need it to multiply to a -24. So one of these two factors has to be negative and add to a -5. So I need the bigger number to be negative, because when I multiply, I'll get a -24, and then a -8 and a +3 will give me -5 when I add them. But now I cannot go straight into my parentheses. So before I would do this. I would say y plus 3 and y minus 8. However, y times y would give me y squared. But I don't want y squared, I want 4y squared. So we can't do that. So let's erase this. Instead, we're going to use factoring by grouping. So what we're going to do is rewrite our original using the middle factors of +3 and -8. So the first term would stay the same. And instead of writing -5y, I'd write +3y and a -8y. Because those are the two like terms that would add up to give me the -5y in the middle. Then my last term stays the same. So now I have 4 terms. And we know that when we see 4 terms, we factor by grouping. So I haven't changed this from the original. The only thing I've done is I've rewritten -5y into those common like terms to 3y and -8y. Those add up to the -5y that I started with. And now I go into my grouping. So I group 2, I group 2 terms. I look for a GCF in the first 2. They only have a y in common. I look for a GCF in the second 2. I notice my leading term is negative, and they both have a 2 in common. I factor out that GCF. So from the first 2 I took out a y. I would be left with 4y plus 3, right? Divide by y, divide by y. The second group, I took out a -2 for the GCF, and I would be left with a +4y plus 3. So again, all I do is take -8y, divide by -2, gives me +4y. -6 divided by -2 gives me +3. If I did it right, my middle terms should be the same. Or sorry, not middle, but the factors that were left should be the same. And they are. I have 4y plus 3 and 4y plus 3. So now that's the GCF that I factor out. Once I take it out, I look at what's left. I have a y minus 2. And there you go. A couple things to note. It does not matter the order that you put the two factors in. So I put my 3y first and then my negative 8y. I could have put negative 8y and then a 3. Doesn't matter. I would have just ended up with the y minus 2 factor here instead of the 4y plus 3. And it doesn't matter the order that I write these factors. Y minus 2 could go first, and then the 4y plus 3, right? Multiplication is commutative. All right, let's look at this one. This one's kind of tricky because it's got x's and y's. But it's not bad because really, if I started with x plus y, and I multiplied this out, x times x would give me x squared. I'd have xy and an xy plus y times y is y squared. Overall, I would end up with 2 xy's in the middle, and I get this form. So when I go to factor and I fill in, I'm going to end up with x's and y's in both terms. So I don't have to overthink it. I just continue on the way I would. I identify, is there GCF? No, there's no like terms here. I've got a lot going on, but this doesn't have any y's, and that doesn't have any x's, and none of the coefficients have any common factors. So there's no GCF. I move on. I see 3 terms. I have to identify my A, B, and C. A is 3, B is 8, C is 5. So A times C, 3 times 5 is 15. So I need factors of 15 that are going to add to 8. So I know right away 3 times 5. I could keep looking for other factors if I didn't see that one right away, but I do see 3 times 5 is 15, 3 plus 5 is 8. Now, again, my front coefficient was not a 1, so I cannot go directly into my parentheses. I'm going to leave my first term the same, so 3x squared stays exactly the same. And instead of writing 8xy, I'm going to write positive 3xy plus 5xy, right? So this middle term is the same thing as 3xy plus 5xy, which are the two factors I found. And then the last term stays the same. So now I see I have 4 terms. 1, 2, 3, 4. When I see 4 terms, I think factor by grouping. So group the first 2, group the second 2. I look for the GCF in the first 2, and they both have a 3. They both have an x in common. I look at the GCF for the second 2. They both have a 5, and they both have a y in common. I factor out that GCF of the first 2. 3x squared divided by 3x, I'd be left with x. 3xy divided by 3x, I'd be left with just y. In the second 2, 5xy divided by 5y, I'd be left with just x. Whoops, and I didn't leave room here. Let me erase that, because I have to remember to write the GCF of 5y. And when I divided that out, I'd be left with just the x. 5y squared divided by 5y would be y. I know that I did this right because my terms that were left once I factored it out match. I have x plus y, x plus y. So now that is the GCF. When I factor that out, I'd be left with 3x plus 5y. And I notice just like up here, as I mentioned, they both have an x and a y in both factors. And that's as far as we can go with that. One more here. This one, I look for GCF first. I don't see anything. Second, I identify my A, B, and C. A is 1, B is 1, C is 3. I want factors of A times C, so A times C is 3, that add up to 1. The only thing that multiplies to give me 3 is 1 and 3, And I notice that there's no way for me to get 1. I can't add these two and get 1. Even if they were both negative, there's no way for me to add up to positive 1. So this entire expression here is called prime. The greatest common factor is 1, and I can't factor that trinomial at all. So if that's the case, all you can do is say it's prime. Go ahead and try the 2 on the right. We are here trying to factor 5x squared plus 13x minus 6. Again, we always start the GCF. Is there anything that all 3 terms have in common? No, so no GCF. Second step, look at the number of terms. I have 1, 2, 3 terms. So if I have 3 terms, I have a trinomial. I identify my A is 5, B is 13, and C is negative 6. Right away, I see my A is not 1, so I have to remember to multiply A times C. 5 times negative 6 is a negative 30. So I'm looking for factors of negative 30 that will add to positive 13. So 30, 3 times 10, or 5 times 6, so on and so forth. I already see I look like I've got a 13 here. The problem is, yes, 3 and 10 do add up to positive 13, but I need it to multiply to negative 30. So I have 2 positives, it's not going to give me a negative. If I put a negative with the 3, now I'm adding up to positive 7. If I put the negative with the 10, I would add up to negative 7. So those are not the factors. Those are most commonly what I see from students, because 10 and 3 do make 13, but they forget about this negative here. So we have to look for more factors. So let's see. 3, 5, what about 2? 2 times 15 would give me 30. And if I put the negative with the 2, it would add up to positive 13. So these are actually the factors that we want. Alright, I keep the first term the same. I rewrite the middle term as negative 2x plus 15x, right? So negative 2x, positive 15x would add to the positive 13x. And the last term stays the same. I have 4 terms now, so I'm going to factor by grouping. The GCF in the first 2 is an x, and the GCF in the second 2 is a 3. I factor out that GCF from both. So 5x squared divided by x would be 5x, and negative 2x divided by x would be negative 2. I took out a positive 3 as the GCF from the second group. 15x divided by 3 would be 5x, and negative 6 divided by 3 would be negative 2. Again, if I did this correctly, then these two should match, and they do. So now the GCF would be 5x minus 2. Once I divide that out, I'd be left with x plus 3. So the other 2 factors there. And that's as far as you can go. We have one more here. Notice that I've got m's and n's. It's going to be the same idea as this x plus y. I'm going to end up with m's and n's in both of my factored terms. But I'm going to approach it the same way. So I have 3 terms. I don't see any common factors. This does not have any n's, this does not have any m's, and the coefficients have nothing in common. So if there's nothing in common here, I go into identifying a, b, and c. A is 3, b is a negative 19, and c is a positive 6. I take a times c. 6 times 3 is 18, and b is negative 19. Sorry, that's kind of sloppy. It's an a. I want factors of 18 that will add to negative 19. Well, right away I'm thinking 1 and 18, but it can't both be positive because I need them to add to a negative. So if I put a negative with both, that would multiply to a positive 18 and add to a negative 19. So those are the factors I'm choosing, but since my front coefficient was not 1, I have to break it up. So 3m squared minus 1mn, right? This middle term is what we're rewriting. Instead of 19mn, it's going to be negative 1mn minus 18mn. The variable has to stay the same as what it was before. The last term stays the same. All right, so now I've got 1, 2, 3, 4 terms. I'm going to factor by grouping. When I look at these first two, I'm looking for GCF. And they both have an m in common. On the second two, I'm looking for a GCF. And I see the leading term is negative, so I'm going to take out a negative. They both have a 6 in common and an n. All right, I continue on. I have my GCF times, divide it out. 3m squared divided by m is 3m. Negative 1mn divided by m is negative 1n. In this case, I'm just going to write negative n. Right, so negative 1n is the same thing as negative n. In the second group, I took out a negative 6n, and I would be left with a positive 3, right? Negative 18, negative 6 makes a positive 3. And then the mn divided by n would be m. And the last term, positive 6n squared divided by negative 6n would be a negative n. And again, I know that I did this right because whoops, let me make that bigger again. I see that I have 3m minus n and 3m minus n. So that is my GCF, 3m minus n. Whoops, don't know where the 2 came from there. And what's left when I take that out is an m minus 6n. m minus 6n. And that's as far as we can go. Of course, you can always multiply this back out, and it needs to give you what you started with, right? You can always check yourself. And there you have it. So if your front coefficient is not 1, you need to find those factors just like we did before, but rewrite your expression with that middle term using the factors you found, and then factor by grouping.